grams per mole gives in 1 mole how many grams is associated. So likewise, we can also say molar volume. We call it as a molar volume, molar mass, isn't it? Number of mass grams per mole can be what? Nothing but molar mass.
Yes, sir.
Like she said. Similarly, you can also call molar volume. What is a molar volume? Molar volume. Sanjita?
Meter cube per volume, like that. Meter cube per mole.
What is 1 mole of any gas going to be? Lower classes, fundamentals. Anyone remembers this number?
Yes, sir.
Yeah, yes.
Remember seen somewhere?
Yes, sir. First lesson, I think so, sir.
First lesson.
So you would have not only first lesson, you would have studied it in your even in your lower classes.
Mass E by N, sir.
Okay.
Heat capacity by number of moles.
No. 22.4 refers to your molar volume. 1 mole of any gas occupies 22.4 liters of. Okay. All right. Next step. Let's see the state of a system. What do you call it? The state of a system. So if the macroscopic properties are going to be definite, what is it? If the macroscopic properties are definite, then the state is said to be definite state. Then your state is definite state. What do we mean by this?
The state is fixed.
Fixed. So let's take the case of pressure. Take a macroscopic property of a gas. Let's say the gas properties such as its pressure or its volume,
Number of moles.
Temperature. Yeah, the temperature.
Gas
Number
constant.
of moles. So all these things. These are all called. They depend upon the temperature, volume. All of these things can change for the initial value and the final value. They may not be the same. Right?
Yes,
So
sir.
all these variables. So these variables can be called state variable or state function. We can call them as state variables or state functions. Now let's take a look at what these state functions are. State functions and path functions. The path is something, what path they follow, how they vary. Okay. Let's try to understand the state and path functions. So it says someone wanted to join, but when I try to see, nobody's there. Not sure who. Alright. So once again, what is the state function? A state function is something of the variables
Independent
which
of
depend.
initial and final.
Absolutely. So those variables which have a dependency on the initial and the final state of a system, but not on the path. Initial and final state of a system, but not the path, are called state functions.
Okay, sir.
So pressure, you don't follow the path. Okay. Volume,
Temperature,
internal energy,
enthalpy,
pressure, energy. Yeah, this is internal energy.
enthalpy.
Entropy. Yeah, enthalpy, entropy. Right. So these are all Gibbs energy, temperature. So all this and many more are all state functions. They
Yes.
don't follow the path, but they have a dependency only on the initial and final values of a system or the state of a system.
Okay, sir.
So, on the other hand, those variables which are also affected by the path, we can call them as path functions.
Yes, sir.
So, state function plus path. So, state plus path is equal to your path function.
Yes, sir.
So, which can I call as path function?
Work.
Work. Work is a path function. Heat is a path function. Okay. The others.
Molar heat capacity, sir.
All are in
Molar heat capacity.
molar heat capacity. Next, we will go to the types of processes. There are various processes are there. We have like 6, 7 processes are in. So we try to understand what are the types of process that are available. What are the various types of processes which are there? So we earlier we heard about adiabatic. What was adiabatic? Along with adiabatic, I used one more name. What was that? Diathermic. Do you remember?
Diathermic.
Diathermic.
Types of boundaries.
Boundaries. When we speak about the boundaries, we saw that. So
Yes.
diathermic was what? Where the heat exchange is
Allowed.
allowed, and the adiabatic was
Heat exchange not allowed.
not allowed. Same thing only here also. Adiabatic process is the one where the system does not exchange the heat with the surrounding. Right? No heat exchange here. No heat can go out or no heat can come in.
Yes, sir.
So the wall which separates the system and the surrounding is called, or actually, when you say wall, it is all the sides of the system itself, isn't it? So it is called as adiabatic wall. What wall? Adiabatic wall. It is a wall which separates the system from the surrounding. Got it. Right. So here, Q, the product of D and Q will be 0. What is Q? Exchange of heat. Hello?
Sir,
Change in heat.
a 0.
dq is Q is the change is 0. Next is isothermal process. Isothermal process. So what is an isothermal process? A process which is carried out at a constant temperature.
dt is equal to 0.
Very good. At constant temperature, this is called an isothermal process. So temperature is constant. So what will be the change in the temperature? It's going to be 0. Right. dE, change in energy, will also be 0. Alright?
How, sir?
Change in energy. There is no change in the energy. Energy is change in
Energy is work by time, sir.
Hmm?
Energy is a work by time, sir. Temperature is not involved.
Temperature is not involved. But when the temperature changes, what happens to the system? Work is carried out. Steam engine.
Okay, sir.
Hmm? As a result of temperature, rise in temperature, work is carried out. But here, it is not possible. There is no change. When there is no change in the temperature, there is not going to be any change in the energy also.
Yes, sir.
Similarly, the next one can be isobaric process. What is an isobaric process? Bar stands for what?
Pressure.
Pressure. Process. Instead of process, I'm writing. So where the pressure, change in pressure, if it is 0, there is no change in the pressure, or the system is carried out in a constant pressure in a process. The process in which there is a change of state is obtained at a constant pressure, we call it as isobaric process.
Yes, sir.
Okay, next we have isochoric process. What is an isochoric process? Isochoric process, a process in which
Volume does not change.
volume remains the same. There is no change in the volume or a constant volume. Right? Volume always remains the same throughout the process. Then it is called as an isochoric process.
Yes, sir.
Right? Next, so far we have seen like 4. Next, so only 3 more is there. Cyclic process.
Everything will be 0 years.
A cyclic process. What is a cyclic process?
It comes to the beginning.
So, yes. So it starts at point, it goes
Ends from at the
another
same
state,
point.
another state, another state. Finally, it comes back to its initial
Yes.
state itself. Right? So therefore, here, in this case, the change of energy will be 0. Okay?
Yes, sir.
Change of heat or work 0. Change in heat 0. All are going to be 0 because the
Yes.
system is going to return to the original state after different changes, after undergoing all the changes. So if you look
Yes.
at the total change, what is it going to be? 0.
Yes, sir.
Right? So such a process is called as a cyclic process. Even though it undergoes so many changes, finally it is going to come back to the original state itself. Right?
Yes, sir.
Next one is reversible process. What is a reversible process? A system where the change takes place very slowly. Okay? Very, very slowly. The change is taking place. Okay. And the direction of which can be changed, can be reversed back. So you have a change that is going to take place. Very slow change is taking place, but the direction can be changed at any point. Okay, by
Yes, sir.
a small, can be reversed by a small change. If the direction can be changed, it can be reversed by same infinitesimally small change. We call it as a reversible process.
Yes, sir.
So this is usually an ideal process. Why we say it is an ideal process is because here the every intermediate state is in equilibrium with the other one. The first state is going to be in equilibrium with the second state, with the equilibrium with the next state, and so on and so forth. The states will be in equilibrium with one another, which is not possible. That's why we call it as ideal process.
Yes, sir.
So if there is a reversible process, what will be the other one?
Irreversible.
Irreversible process. What is an irreversible process? Okay. So
You
wherein
cannot change its direction.
direction cannot be changed, it cannot be reversed by small changes.
It takes big steps, sir.
Yeah, so all natural processes are irreversible processes. Okay. So the total work done in a reversible process is going to be less than the work done in a reversible process.
Yes, sir.
Work done, total work done in an irreversible process will be less than the work done in a reversible process, which we will be seeing in our following classes.
Yes, sir.